Okay, in this video, we're gonna discuss mole calculations of STP gas. So we have learned that moles are very centered concept in many calculations. For example, going from mole, you can in one step you can going from mole to get mass or convert the mass to mole, either by having the molecular weight or molar mass of the elements. Molecular weight is basically the molar mass of the element of the compound. Or you can go from mole and go into mole from a number of or either atoms or molecules. Depends on what you're calculating the nature of the chemical. If you're dealing with the mole of elements, then you're counting the atoms. If you're dealing with the mole of compounds, then you are dealing with counting the molecules. Now, obviously, there's space for one more branch, okay? So this is going to be the relationship between mole and STP gas. So the relationship between the STP gas and the mole concept here is this. Every 1 mole of any gas at STP is equal to 22.414 liters. Or you can write it as 1 mole STP gas equals to 22.414 mole. Or you can say 22.414, I'm sorry, not mole, liters. Okay, 414 liter. Okay, every 1 mole STP gas equals 22.414, or you can say 22.414 liter per mole. Okay, so it's more like a molar volume, and this is a universal number, okay, constant for any STP gas. But the question is, what do you mean by STP gas? Okay, first of all, STP stands for standard temperature and pressure. Standard temperature is basically 0 Celsius degree or 273 Kelvin. You can ignore the 15, okay, it doesn't matter. Standard pressure is 1 atmosphere pressure. This is a unit of pressure, okay, or you can write it as ATM. Gas, of course, you know, it's gas. Any gaseous phases, okay, under this temperature and pressure, it doesn't matter what kind of gas, doesn't matter if it's a single element gas like a hydrogen, argon, or it's a compound or molecular gas molecules, carbon dioxide. 1 mole of these things are always going to be 22.414 liters under this temperature and pressure. So when people say gas at STP, that means basically you can use this number. Okay, so you can see every 1 mole is 22.414 liters, or how many liters is how many mole. You can do that kind of conversion. It's kind of like a molar volume for gas, okay, but can't overaddress this, okay, it's only for gas. Okay, doesn't matter what kind of gas, but it has to be gas. Okay, you cannot deal with either liquid or solid or aqueous solutions using this 22.44 number. Okay, now let's take a look at this. Let's take a look at this using this flow chart to deal with more different problems. Okay, so okay, see if we can have more space here. Now, by looking at this flow chart, okay, you can see one thing that's very clear is that if you have any dimension, okay, either you have grams, you can go from mass to liters, or you can go from liters to number of molecules, molecules to grams. So you can molecules to go to liters, which you don't need the molecular weight. It depends on what conversion you are trying to get. Okay, there are a lot more possibility now by having three branches, 3 corners of the triangle. Okay. All right. So let's look at a few more example mole calculation here. Right. So if you have 5 mole of ozone gas has a formula of O3. Can you find how many liters at STP? So at the standard temperature pressure, can you find the volume of 5 mole of ozone gas? Alright, so this will be fairly straightforward. 5.00 mole O3. As usual, you want to write down all the numbers, units, and the chemicals. Multiply by. Since this is going from mole, okay, let me rewrite this, readjust this. Okay, mole is in the center of all of the calculations. Okay, so going from mole to anything or going anything to mole is going to be just one step. Okay, so this is going to be one step, 2 liters. Mole of O3 going to be down here to be cancelled. Liter will be on top. So this will be 1 mole is 22.414 liters. So it's independent from the chemical composition of the gas itself. Okay, so it's 1 mole 22.414. You basically multiply the number 5 by 22.414. Okay, so and also I'm sorry, forgot to mention this. 22.414 here is going to be, it's always going to be exact number. Okay, always going to be exact number. So you only need to count sig figs the first number, which in this case 3. Okay, 112 liters. All right, so let's see if we can try another one here. If you have 45 mole of oxygen gas, how many liters? Or you can pause here, quickly try this one. So you almost can copy the work from previous one to do this one. It's exactly the same thing. Okay, you can see that it doesn't really matter if this is oxygen or ozone. Okay, you can multiply this number by 22.414 on top, 1 mole at the bottom, liter on top. The only thing you want to be careful is this one. It only requires only 2 significant figures. The number coming out from the calculator is going to be 1,008 point something point 0.6. Okay, now you're going to round this down to 2 sig figs, but you have to keep it 1,000. The only way you can do this is by using scientific notation. Okay, 1.0. All right, so let's take a look at another one. Okay. Now, if you have 3,067 grams of CH4 gas, can you find how many liters at STP? Now you can see this is going from gram to, which is on top here, to liters here. So you have to go through the mole as the intermediate. Okay, 2-step calculations. So 3,067 grams CH4, 2 steps, and you're gonna get liters at STP. Now, keep in mind, okay, with 2 steps, you have to know what you're trying to get in each step. Okay, in the first step, you're trying to convert grams to mole. In the second step, you're trying to get liters from mole. And of course, we're dealing with CH4 everywhere. This is very important, okay? You have to make sure you know which compound you're dealing with. Now, since you're going from gram to mole, okay, you have to find out the relation between mass and mole here. That's going to be the molecular weight. So the molecular weight of CH4 is 1 mole of CH4 weighs, carbon is 12.01, hydrogen is 1.01, but keep in mind there's a 4 here, so it's going to be total 16.05 grams. So it's going to be 1 mole of CH4 weighs 16.05 grams. Make sure you put the number in the right place, okay? So mole is on top, 1 mole, grams at the bottom, 16.05. So this is something we've done a lot of times. Mass divided by molecular weight, get the mole. Okay, and then the next step is converting mole to liters. 1 mole is 22.414 liters. This number considered to be a constant, okay? Universal constant for all of the compounds. So basically 3,067 divided by 16 times 22.414, you're gonna keep 4 sig figs. So and you're gonna have 4,283 liters. All right, so one more here. Now, if you have 6.90 times 10 to 12 molecule molecule, okay, of sulfur dioxide. This is not sulfate or sulfide. This is sulfur dioxide. This is a neutral compound. This is not an ion, okay? Now, you want to find out how many liters of SO2 at STP. Okay, this is a gas. This is a gas, okay? So this is going from molecule to liters of STP gas. Again, you have to go through the mole as the intermediate. 2 steps. Okay. Now by starting, put it down 6.90 times 10 to 12 molecule SO2. 2 steps. At the end, you should get liters at STP. Now the first step is going to be finding the mole. So you probably learned that, okay? The key step is always finding the mole first, and then molecule down here, so you can cancel the molecule of SO2. The relationship between mole and the molecule, or mole and the atom, is always going to be 1 mole 6.022 times 10 to the 23rd. Now keep in mind, okay, it's not like you have to use molecular weight everywhere. This is not about the mass. There's no mass here, so you don't need a molecular weight. Okay, you basically divide this number over the Avogadro number. Make sure you parenthesize this in your calculator, okay? So you get the mole. Now once you have the mole converted into liters, every 1 mole has to be down here, so you can cancel it, okay? You have the 1 on top, 1 on the bottom, cancel it. It's going to be 22.414 liters. Alright, so this number divide by Avogadro number, multiply by 22.414. Again, you don't really use molecular weight in this case, simply because there's no mass number involved in this calculation. Now, you keep 3 suffix, okay, 6.90, 3 suffix. So at the end, you're going to have a number fairly big, long, 2.61 times 10 to negative 19 liters. Okay, so you can see, essentially, this is very similar to all the mole calculations we've done before, except we're using a new number we've never learned before, 22.414. Again, I can't overaddress this, okay? Gas only for this number. Gas only to use this number, okay? All right.